Hello everyone, this is Bradley. So today we're going to make this procedural weaved iron chain. Please remember that you need Blender 2.82 to follow this tutorial. The reason is that due to some changes in Blender 2.82, the developer of animation nodes changed some codes and make certain nodes not working in Blender 2.81. Another thing is that you can download the project file for $1 on Gumroad. The link is in the description. Also, to know how parameter works, or what you can get from these files, you can go to watch the demonstration, whose link is also in the description, or you can go to the cards on the right upper corner of this video. So the entire principle of this modeling is all about sine wave. So I need a float math, float range, and a combine vector. These three nodes. So I input a lot of numbers into the sine function to construct a wave, plug results to y, and list it to z. So now if I take a 3D viewer, you can see I have a very tiny wave here. And if I increase the amount, then it becomes a longer wave. And I want to change this type into stop so that I have more precise control in the height of this entire thing. Then I'm going to construct a spline from all these points. Smooth bezier splines, curve objects, output. Spline to splines, set the bevel depth to 1, and take a target. So now we have a spline, very cool. But a single spline is obviously not a eevee pattern, so we need to replicate the splines. And I need the metrics to define how to replicate it. So let's do only replicate on y, metrics into transform. I need to set the type into step so that even if I increase the numbers, it just expand itself very nicely. But obviously they are not crossing each other, so this is not what we're looking for eventually. So how can we actually do this? A way to do is to use offset matrices and set the rotation to 180 degrees. And by changing this green fold, we can define which one actually rotates, which one does not. So here I'm going to call a index mask fold. So every second of them will rotate 180 degrees, while the others not. This is it. Very simple. So the next thing that we're going to do is make all these splines crossing each other. It's fairly simple to do. You just make a cosine wave and put that to x. So you can know more from Wikipedia, but what I can say is cosine wave is just a sine wave that differs its phase by 180 degrees. So if this is the sine wave, when the sine wave is at the peak, the cosine wave is at 0. So this is cosine wave, and that's how it looks. And now they are crossing each other, but it looks like over exaggerated, more kind of double helix. So let's just take a math to divide by a certain number, like make it 5 should be good enough. So now they are crossing each other while it's not very exaggerated. This is kind of cool. Another thing is I want to have the ability to increase the frequency of these waves. So I'm just going to plug the multiply and set it to 2 should be enough. You can realize if you increase the frequency too much, this entire wave looks completely weird. And I said as in other demonstration is you just increase the resolution, it'll be fine. But in this case, I'm just going to keep that like this. So I think after this moment, it's possible to just construct everything. So I take this as a resolution, height, multiply, so frequency, parsing division, instances, separate. So now if I hit Ctrl H, then it will collapse the entire thing. Basically make everything more neat. And I'm going to plug a smooth. So if you have watched my demonstration, you can realize if the smooth is actually a very interesting number, it can generate kind of flower patterns. So something like this. And you can increase the separate, or you can decrease the separate to make it kind of interesting. And if you increase the resolution, then all these flowers, it is kind of very interesting pattern things. And DC also tends to be a reason which it might be better than model that, because I cannot imagine how you actually model these things. A very kind of interesting flower pattern. Another thing is this bevel depth. So after this moment, this tutorial has been done. But some other things I would like to mention is when I was making these things, I want to have this turning point sharper. So the way I do is I'm going to use a map range node. And I'm going to interpolate that. So a sine wave goes from -1 to 1, and I'm also going to output -1 to 1. So nothing has been changed at this moment. But I'm going to use a curve interpolation node and plug that into. And be aware that I always turn off the always auto execution, because it will basically burn your computer. So the issue, however, is this curve interpolation node will not auto update itself. So even if you change the value here, you won't see any change in the viewport. But as soon as if you change a time frame, then you can see all these changes. So this is the part you can manage, or you can simply just turn the always on and change that to your wish, and then turn this always off. So this is kind of ways to do these kind of things. I think now this is good enough. Another thing is this curve interpolation node is the reason why you have to use Blend 2.82. But if you are not using this node, actually it's not very important. You can just use Blend 2.81. So this is all about it. I think I have nothing more to actually mention. Another thing is that you can transform splines actually. And let's get a object matrix input. So I'm going to create an empty. So I'm just going to name this empties. So now what it happens is I will put this empty to control. The reason is I've already set all these triggers in this control, so that if I update these empties, the tree will be executed since I'm turning the always off. So now if I use this empty, you can see I can scale down and up, and I can even rotate that, move that as you wish. So it's just kind of things which is more convenient to manipulate. And that's the basic point. I think this tutorial is really done. I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.